Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah, I'm blessed with another day to live, and therefore I am also blessed to continue doing this effort of environmental information, knowledge, sharing of my experience and my work and what I learned from other people with you again. And thank you. I'm also honored for those who are kind enough to subscribe to my humble channel. I hope I live long enough to pursue more informative videos to help out, especially university students, lecturers, auditors, competent persons, and all others who need this information to enhance their work. I hope this information is able to bring goodness and happiness to all of you. Right, we'll continue today with another type of industry which is listed in the first schedule. And this industry is quite common, and actually it's not really categorizing a industry, but it's apparently for this particular part J are industries that uses solvent. Any industry that uses solvent. Apparently, solvent is an important material. It's a kind of surfactant as well. It is being commonly used in various types of industry. We'll discuss it. Now, why we are here, let us take a look again, especially for those who pop into this video without watching earlier videos. Let me give you a recap of what we have done. Now, as I said earlier, how do we identify our application of this particular regulation, Clean Air Regulation 2014? As I said, look at Regulation 13. And in Regulation 13, it mentioned the word activities listed in the first schedule shall subscribe to emission standards listed in third schedule. So here we are. This is the first schedule, and we are here because of this. We are going to discuss industries which uses a lot of solvent. This is a lot of solvent, 200 metric tons per year. All right, and we are going to discuss what the law wanted from these industries that has been using solvent in that amount, more than 200 metric tons per year. I believe you are well aware of the life cycle perspective as stipulated under ISO 14001. If I'm blessed with time and also longevity, I would discuss that with you so that you master the topic, and you can adopt it in your existing 14001. You can go anywhere in the world without being caught not knowing or confused with the term environmental aspect. We'll come to that hopefully many videos from now. Okay, now this industry is using more than 200 tons of solvent per year. What sort of industry? It can be any industry, and excuse me, and those industry may be as listed here, what you have, but also those industry might not be listed in the first schedule yet so far, from A, B, C, D, E, F, G, H, I, and now J. And this industry might not belong to any of the above industry already discussed. So let's take a look. What sort of industry is applicable to this one. Now back to what we have done before. Remember, this is the key to this regulation. Check whether we are belonging to the first schedule. And remember, the law says activities listed in the first schedule shall conform to the limits, emission standard and parameters stipulated under third schedule. And there, as you have seen, there are some notes, okay, below this table, and those notes sometimes might link this sort of parameters in the third schedule to especially the fifth schedule. That is a worry to me. It can lead to confusion and also discomforting to many industries, because they've got to work to and fro from these two schedule. But don't worry, what we need to do is to determine if in your third schedule mentioned that you got to look into the fifth schedule, you determine which parameter in the fifth schedule is applicable to you. We'll discuss that in some other time. All right, now let's take a look. Next slide. Okay, I believe the picture is quite common to most of you. Now, according to this law, Regulation 13, it mentioned the word in particular. Solvent used in industry, in particular organic solvent. Now, any kinds of solvent is regulated here, in particular organic solvent, and most of these activities is applying what is called surface treatment of usually parts, components of certain products being manufactured. For example, the picture is showing you a kind of automobile assembly line, and this body has been made from maybe metal stamping. Before that, it could be aluminum, it could be steel, it could be some other metals that can capture dust, if not corrosion, especially at the welding parts. All the joints are welded, and it could lead to corrosion if it is exposed for too long a time. Therefore, solvent is being used in cleaning or removing the rust or preserving the surface of these metals. The application is known to industry. They have a system, they have methodology, engineering to use solvent. Now, what we have here is that when organic solvent is being used, or organic solvent is in particular, it can be any other solvent, all right? One in dressing, okay? Dressing is like, there are some processes involved in dressing, is like removing, it may include removing of dust. It's not just about yarn and textile, but it may include the removal of dirt or particle matters on surface of material. It can be dressing, meaning making it beautiful, including beautifying it, making it more authentic, or making it more, having a higher aesthetic value, and all these things. All right. Also, the printing industry. This one is a printing industry whereby we use a lot of solvent in the printing industry. It could be the printing of newspapers, books, or whatever, printing of carton box, inclusive printing of what do you call banner, etc. All this printing uses ink. And as you know, when we use ink, we got to mix ink with solvent. Normally, it could be benzene or xylene. All right. And when ink is being mixed, it depends on water-based ink or oil-based ink. Water-based ink still uses xylene. So solvent is being used in printing. And from my experience, the most critical part in a printing industry is when they have to change color. When they have to change color, normally the printing machine, the parts of printing machines which were in contact with color will have to be cleaned up before they change into the next color for the next product or for the next client. All right. And normally it involves photographic plates, printing rollers, trays, jiggers, hoses. All this equipment has got to be cleaned first before they run the next color of ink. And the mixing of ink is also using sets of solvent, and for this industry they do use a lot of solvent. And when if you have attended my class on hazardous waste minimization technique, I think I have showed you some of the, well, one case study in that module, one case study which is done by local university to reduce the consumption of ink in the printing industry. So solvent can be reduced. The consumption of solvent can be reduced when we have the right method of doing things. All right. And also in coating, some solvent is being used to coat certain materials. All right. Um, I'm not sure if zinc phosphate, what do you call it, EDP, they call it, electrolytic zinc phosphating. All right, and it's a form of coating to ensure that when they do painting with the zinc compound in the coat, it will have a very good stick of color pigments or paint with the surface of the metal that is coating. And in some cases, the industry has got to remove grease from metal parts. In engineering, as you know, some of the components of engineered products or components, uh, they were being assembled into product not on the spot. These components were made in mass, huge amounts, and they have got to be kept in inventory, meaning they will be idle for a while, and then transported to the end user before it is being assembled into a product. So that time between manufacturing to use is a lot of time. It could be months, it could be years, all right, it could be days. But as you know, metal surfaces gets oxidized, and production engineers needs to ensure that these metal surfaces does not get oxidized in order to ensure the end product quality is at prime level. So they got to remove the grease when they got this product. When the product is being produced, it is being coated with some form of oil. It could be paraffin, it could be some other oil, it could be some oleochemical sort of oil. There's a lot of now green products around. So when they go into, when they are being, when these products, which is oiled, arrives at the end user has got to remove the oil coat, which is the protective layer from oxidation and from rusting. So the removal of this oil is usually using solvents, and then they're being dried, and so on. They go into the next processes. All right. And also waterproofing, they use solvent. I am not having enough knowledge in waterproofing, but normally waterproofing, they use solvent in the making of the proofing coat. It could be amine group, it could be acryl group of chemicals, which is enhancing waterproofing of products which is manufactured to be waterproof. All right, so there's involving the use of solvent and the manufacturing of waterproofing coats. As far as I know, you can add. All right, my knowledge in this might be is limited, definitely. All right, and sizing. I'm not sure about sizing, but I think if you're in the metallurgical industry or in the yarn textile industry, you know this. All right, and it's being used. Solvent is being used. All right, some physical properties of solvent due to the, I think, is suitable for that particular process. And painting, in painting, well, in the production of paint, yes, solvent is being used, combined with binder, combined with pigments, combined with many other materials in the manufacture of paint. And normally, to ensure the high premium quality of paint, fresh solvent is being used. Nonetheless, due to a resource conservation campaign, as you know, solvent is from oil and gas, all right? And to ensure that we are able to conserve resources, well, my suggestion to many, why don't we just recycle the solvent by having a solvent recovery unit? And then we can add in solvent to have their desired physical properties like surface tension, to look into their vapor pressure, to look into their solubility and solubility properties and all other solvent properties. If we can maintain that quality, I think there shouldn't be a problem for us to recover used solvent and to use them again in new products. All right, so others are cleaning, like probably in metal fabrication, cleaning or impregnating, even in metal stamping. After you have done metal stamping, then you got to degrease them. Yeah, same thing. And also in cleaning, or even in semiconductor, electronic factory, they use solvents like isopropyl alcohol. They use butanol, propanol, all right, and it depends on the product and the purpose of the solvent. The purpose of that process, the solvent would suit into the purpose, and these are all product engineering designer would come up with all these ideas to have conductivity, to have all other electrical or electronic properties, stabilized. I'm not an expert in that, but I learned from them, and that's what they told me. They have got to use it in some electronics and semiconductor industries, and also in the fat extraction. Yeah, some solvent is being used. I think in some plants whereby they want to remove lipids, or they want to remove layers of fat from a solution or from their product by using solvent. The fat would dissolve in solvent, and they have products which is free from or less fat content. And it can also be used in some industry. Don't be surprised if it's used in the food industry as well. We have seen it before. All right, so the law says, what does the law says? We have to come up. Now, who is subscribing before that? Who is subscribing? If our company is using more than 200 tons per year of solvent, then we are subscribed. We are subscribed to this particular regulation 13, third schedule J, solvent used in industry. What does the law wants us to do? We are required under the law to come up with an environmental management program called Solvent Management Plan. What's the purpose? To reduce. See, the purpose is to reduce consumption of solvent. We need to have a plan that has got reduction targets, and we need to have what is called best available technique, economically achievable, and to ensure solvent losses shall be below 30%. So we need to have a mass balance for our solvent alone. We need to know how much volume of solvent we take in before the process and how much solvent is being lost. So we have got to look into how much solvent is being used and how much solvent is left. In between that are those solvent which is lost. So solvent lost is the most important part here. We got to make sure less than 30%. And solvent loss, I believe, is measured by volume, or it can be measured by weight. The law doesn't say volume or weight specifically. You choose. As long as you're able to provide evidence to the authority or the auditor that your losses is less than 30%. So you need to have that best available technology, economically achievable in a form of document, meaning you have to describe what are you doing or what have you been doing to ensure that your solvent, that our solvent losses is really below 30%. And we have got to describe the methodology that we measure that 30%. So that is quite concise. We have got to have a document, okay, have a black and white methodology, not just a target, to reduce less than 30%, not just target, but we need to have methodology, mechanism. What do we do? Including if we have got to install certain gadgets or we have got to adopt certain process technique, write it down. Including if we have to buy a solvent recovery system, write it down. If that solvent recovery system justify that we are able to reduce losses less than 30%, be it. Got it? And then we have got also a case-by-case basis on the guidance document on fugitive emission control. So for solvent, I think you know, solvent is having some amount of vapor pressure. It is volatile, therefore it emits into the atmosphere or the air above it some form of volatile organic carbon, depending on the type of solvent that you use. As far as I'm concerned, even isopropyl alcohol emits VOC, benzene, xylene, toluene, pyridine, naphthalene, you name it. Methyl ethyl ketone, methyl tributyl ethylene do emit some form of volatile organic carbon in the air. All right, so even paint, yeah, you know, the moment you open a paint can, you can smell. When you can smell, that is an indication that it is emitting volatile organic carbon. So this is what the law wants. Yeah, I believe my explanation is brief and clear, and you are able to comprehend, and hopefully with that you're able to apprehend. Remember, Betty has got to be documented, it will be an evidence. The law doesn't say that, but you have to provide evidence to the authority and the auditors how to do it. You can't say much during an audit, so how to display your evidence is when it's documented. That's the best avenue. All right. Of course, documented doesn't mean printing. You can have it in soft copy. Yeah. Okay, so I believe I have given enough for the day on solvent. We'll meet again in the next video. Thank you for your attention, and thank you for your subscription and those who have not subscribed. If you want more and if you want to be notified, or if you want to have a constant feed of my video to you, please subscribe. Then it will be yours in your desktop whenever I upload. All right, and it can help you in all the coming years. And I honestly I believe in ensuring education is accessible to all in this manner. But not occasionally, I have to make sure for my life and my family, I've got to make ends meet. That is why I still do public training. With that, I'm able to bring food on the dinner table. That's understandable, isn't it? So I believe it's fair for everyone. I hope you enjoyed this, and please benefit from this. I end this video with my best wishes to everybody. The new Hijrah year is coming, so I wish everybody Assalamu alaikum wa rahmatullahi wa barakatuh. Have a good day, have a good week, and enjoy your work and your studies. Bye bye. Take care.